In today's lesson, we are just going to do a brief overview of calculating volume. So we've already looked at area and perimeter. Perimeter was the distance around an object. Area was the amount of space a 2D object takes up. Volume is the amount of space a 3D object takes up, or the amount of space or the amount a 3D object can hold. So if we imagine these objects as kind of shells or cups, if we were to fill it up with water, the amount of water in there would be the volume. So we're going to kind of just review just making these calculations and just kind of getting comfortable with finding volume of certain objects. So we are going to look at 4 different shapes here: a cylinder, a square-based pyramid, a rectangular prism, and a cone. So we do have formulas for these, so you don't have to worry about trying to memorize these or come up with them. You will have formula sheets, or you will be given formula sheets here. The main thing is the way the formula sheet works. We have the very base formula, or the very generalized version, up top, and then we have the specific ones on the bottom using the actual measurements, or the actual, indicating which sides we're going to be using when we make those calculations. So just be careful and make sure you're using the correct formula. So if we look at the first one, a cone, going back to that formula sheet, not a cone, a cylinder, my mistake. If we look at the cylinder, we can see that the formula here is the area of the base times height. And generally speaking, when we have perimeter, volume of kind of these prisms, this is the general formula, and you'll see that throughout: area of the base times height, because basically it is the area of this bottom, or this circular face on the bottom, and then we have, you could argue, slivers going all the way up for the entire length of the height. So that's kind of where we get this formula from. So our volume formula is pi r squared h. So if we go back here, I'm going to write this down. Volume equals pi r squared h. Pi, again, remember, is 3.14. So we'll just write up here. We will come across this again. Or you can find the pi button on your calculator. Again, either one is fine. R squared is the radius. So here, we're not given the radius. This measurement here, this is the diameter. I want the radius. So the radius is actually half of the diameter. So half of the diameter here. So R would equal 8 divided by 2, which is 4. I'm going to draw in this line here just so we know. The diameter is the distance across. The radius is half of that, or 4. I already know my height. It's given to me. So in this case, I can just do 3.14 times the radius squared, or r squared, and then times the height, which is 12. Now this should be a straightforward calculation. The only thing you want to be aware of is that you have to do the exponent first. So you do have to follow BEDMAS, or the order of operations. So 3.14 times 16 times 12. Again, if you were to enter it all in on a calculator and you did it correctly with no issues, you could do that entire first line on its own and you would get an answer. But again, sometimes it doesn't hurt just to take an extra second or an extra step just to make sure we do have the right numbers. So 602.88 is going to be the volume. Now in terms of units, it's going to be centimeters cubed. So the thing with units and volume, units are cubed. So you're going to see that exponent 3 above the units. So that is the difference when dealing with volume. Our units are cubed. The next one, this triangular based, or this pyramid, this square based pyramid, if we go over to our formula sheet and look for it, we see we have base times, or base squared times height divided by 3. So volume equals base squared times height divided by 3. So base squared, or in this case, is going to be base, my base isn't quite a full square, because we see 14 by 9, so we're actually going to have to do length times width times height divided by 3. The reason the other one was base squared was because it was a square so that these two sides were the same. In this case it's not, so we have to alter our formula slightly. So 14 times 9 times 20, all divided by 3. Again, I would simplify the top first. So 2,520 divided by 3. Now we get 840 yards cubed. So again, you could do this all at once in one calculation if you're comfortable using your calculator. If not, take the extra second to just break it down, do one extra step just to make sure you get the right answer. For a rectangular prism, this one we should know this formula off, or as kind of one of the common ones, length times width times height. Again, if not, you do have that in your formula sheet. So here, again, when we're dealing with this, it doesn't really matter which ones go where because it's all multiplying, and order doesn't really matter when we multiply. And again, you could orientate this shape in different ways so that the 3 could technically be the width, or it could be the height, or it could be the length. As long as you have your 3 numbers in there, you should be good. We end up with 240 millimeters cubed. Lastly, our cone. Our cone has a specific volume. In this case, this one might be not as common, so we will have to go to our formula sheet. Our cone, we have the area of the base times height divided by 3. So pi r squared h divided by 3. So there is a relationship between the cylinder and the cone because it's very close in terms of our actual formulas. So there are relationships between the volumes of these certain shapes. So the volume is going to be pi r squared h divided by 3. Again, in our formula, or in our shape, we're given the diameter of our object, which is 7. We just want to be able now to find the radius, which would be half the diameter. So half of 7 is 3.5. So we just got to be careful when we're dealing with some of these shapes, especially the ones that have circles. We want to make sure that we know the radius when making these calculations. So pi is 3.14 times the radius squared, so 3.5 squared, times the height, which is 13, all divided by 3. Again, when dealing with these types of questions, I want to try to simplify it as much as possible first. You could do it in one step on a calculator, but again, take that extra second. And again, remember, you have to deal with the squared first, following your order of operations. So 3.14 times 3.5 squared, which is 12.25, multiplied by 13, all divided by 3. Again, I'm going to take that extra step and calculate what the top of my fraction is first. I get 500.045, and then I'm going to divide that by 3 and get 166.68 inches cubed. So again, this was just a quick review or a quick overview of calculating volume of specific shapes. The main thing is making sure that we have all the measurements when dealing with any 3D object that has a circle in it. We want to make sure that we know the diameter and the radius. The radius is the most used one in the formulas, so that's why we need to figure that out. Again, remember the radius is half the diameter, and then making sure that in the end, once we do our calculations, our units are cubed. Right? So the units will be cubed when dealing with volume, which just means there's an exponent or to the power of 3. But again, you do have your formula sheet, so as long as you can figure out the correct sides and the correct measurements and put them into the correct spot, it just boils down to a calculation.